All right, let's find the inverse of this function g of n. Okay, step number one, what we're going to do is we're going to put it as y equals negative 12 minus 2n over 3. Okay, step number two, what we want to do is we want to switch the y and the n. So now we have n equals negative 12 minus 2y divided by 3. Okay. Okay, next step, what we want to do is we want to solve for the variable y. Okay, so the easiest way that I know to do this is through a Vedic word formula. The Vedic word formula is transpose and apply. What that means, transpose and apply. If you guys have ever heard of the term reverse engineering, you know, like the U.S. government found a UFO at Area 51 and they reverse engineered it. You know, you've heard this term reverse engineering. It's kind of what we're doing with these when we're solving for y. We're just going to reverse everything. We're going to reverse the operation. So here we're dividing by 3, so we need to multiply by 3. So we're reversing. This is this transpose and apply. So we're transposing it. We're doing it across the equal sign. So what that means is transpose and apply is let's just reverse all the operations until we get this y by itself. So we're just going to be reversing everything. So our first step is, since we're dividing by 3, we need to multiply both sides by 3. So now we have 3n equals negative 12 minus 2y. Okay, step number 2, what we want to do is we want to add 12 to both sides. Okay, this is reversing. We're reversing, right? Here it's being subtracted. So we're going to reverse that. We're going to add 12 to both sides. So now we have 3n plus 12 equals negative 2y. Okay, now to get y by itself, what we need to do is, right here, this is being multiplied by negative 2. Y is being multiplied by negative 2. So to reverse that, we're going to divide by negative 2. So now we have 3n plus 12 divided by negative 2 equals y. Okay, once you get to this point, you're done. This is the inverse. So then you could go ahead and write it like this. You're going to say g of negative 1, or the inverse of g of n, equals 3n plus 12 divided by negative 2. And this is your answer. Okay, once again, I just want to point out that this negative 1 is not an exponent. This is your function notation. This is just saying that this is an inverse. It's inverted. We just inversed. We inverted this function. Okay, our next function, f of n. Okay, so our first step is we're going to say y equals negative 5 plus 6n all over 5. Okay, step number 2, remember we're going to switch the n and the y. So now we have n equals negative 5 plus 6y over 5. Okay, then just go ahead and solve for y. So we are going to multiply both sides by 5. Why? Here we are dividing. So to reverse engineer this, here we're dividing. To reverse it, we need to multiply both sides by 5. Okay, so now we have 5n equals negative 5 plus 6y. Okay, once again, we have a constant. Usually you want to attack the constant before you attack this coefficient to your variable. Okay, so here we're subtracting 5. To get rid of that on our right-hand side, we got to reverse this operation. So we're going to add to both sides. We're going to add 5. So we have 5n plus 5 equals 6y. Okay, now we are multiplying y, we're multiplying it by 6. So to reverse the multiplication, we're going to do division. Basically, we're going to divide both sides by 6. Okay, that cancels out. What we're left with, we have 5n plus 5 over 6. This equals y. Okay, so now that's pretty much the last step once you get down here to your y when it's by itself. So now we're going to say f negative 1 of n. The inverse of f of n equals 5n plus 5 over 6. Okay, there it is. There's your inverse. All right, f of x. Let's find the inverse of this function, f of x. So we're going to say y equals negative 4/7 x minus 16/7. Step number 2, we're going to switch these variables y and x. So now we have x equals negative 4/7 y minus 16/7. Okay, so first thing we want to do is you always want to attack these constants by itself. You usually save these terms that are connected to your variable y. Usually save these for last. So we're just going to go ahead and add both sides by 16/17. Or excuse me, 16/7. So we have x plus 16 over 7 equals negative 4/7 y. Okay, next step. You could go about this next step 2 ways. I'm going to keep it consistent with how I did earlier. So I'm going to say x plus 16 over 7 equals negative 4y over 7. Right? If you see a fraction being multiplied by your variable, you could rewrite it like this. Okay. Next, what I want to do is I want to multiply both sides by 7. So I have 7 times x plus 16 over 7 equals negative 4y. Next, I want to divide both sides by negative 4y, or negative 4. So divide by negative 4, divide by negative 4. Okay, what we're left with, we have y. Y equals, now kind of like how I did here where I switched this fraction and I kind of wrote it like this, I could do the same thing with these here. This is just a fraction being multiplied by this. So what I could have is I could say negative 7/4 times x plus 16 over 7. Okay, I just want to point out that if I have, 7x divided by negative 4, this is just an example, it has nothing to do with what we're working on, but just an example, that I could also write that as 7 over negative 4x, or negative 7 over 4x, or negative 7/4 x. Okay, this is going back to your rules with fractions. If you have a minus sign in the denominator, it's the same as having a minus sign. You could just move that sign up, or you could move it all the way. You can move this sign kind of in the middle, if I can move this. Well, what I mean to do is there, like that. So you can have this minus sign kind of right there in the middle. Okay, this is just going through your fractions. So that's basically what I did here. I just have 7 over negative 4. That's saying negative 7/4 times this these terms here, this expression. Okay, so now I'm going to say, since y equals all this here, I'm going to call that f, the inverse of f of x. I'm going to say that's negative 7/4 times x plus 16/7. Okay, there it is. There's our answer. Okay, this next one's going to be kind of tough, but let's get through it. So first step, we're going to say y equals 2 times n minus 2 cubed. Second step, we're going to switch the variables y and n. So now we have n equals 2 times y minus 2 cubed. Okay, next we want to kind of reverse engineer this here, this term. So here it's being multiplied by 2. We want to divide by 2 both sides. So we have n divided by 2 equals y minus 2 cubed. Okay, next thing I want to do is I want to take the cube root of both sides to get rid of this exponent. I'm going to take the cube root of both sides. So we have cube root of n over 2 equals y minus 2. Now we want to add 2 to both sides. So cube root of n over 2 plus 2 equals y. Okay, now I want to kind of point this out that we're not really done at this point. What we need to do is work on this portion of it. And we want just these root signs in the numerator. So I'm going to kind of show you how that's done. Basically what we have is, okay, I'm just going to take this portion of it, and I want to put that up here. Cube root of n over 2. Okay, that equals the cube root of n divided by the cube root of 2. Okay, that equals the cube root of n divided by 2 to the 1/3. Right? If I have a cube root, it's the same as a fractional exponent to the 1/3. Okay, now what I need to do is I need to multiply this by some number to get rid of this fractional exponent. Okay, so what that number is going to be is 2 to the 2/3. Okay, so I need to multiply it by, this is rationalizing the denominator. This is rationalizing the denominator. That's what we're doing here, rationalizing the denominator. So I'm multiplying it by 1. Any number over itself equals 1. So if I take this term and I multiply it by 1, I'm not really changing this. Okay, this stays the same, because any number times 1 is still that original number. I'm just changing the way it's being perceived. So the denominator, what you have is 2 1/3 plus 2/3. Remember your rules for exponents. When they're being multiplied together, if you have the same base, your exponents are being, you're multiplying these together, that these exponents are going to be added. Okay, and they're going to be added. So I'm multiplying. This goes back to your exponent rules. In the numerator, I'm going to have cube root of n times the cube root of 2 squared. Okay, 2 2/3 is the cube root of 2 squared. So then what we're left with is cube root of n times cube root of 2 squared divided by 2. Okay, 1/3 plus 2/3 equals 3/3. But 3/3 is just 1. So that's just being 2 raised to the first power. And that was the point. That was the point of doing all this. We wanted to make it so there's no root signs in the denominator. Okay, so we did all this, so we have this 2 here. It looks like this now. So then we could say that this is cube root of n times 2 squared over 2, which equals cube root of 4n over 2. Okay, so I did all that to change this. Remember, we're doing our inverse. We got to this point, and I wanted to change this, because when I write this out, it looks something like this. I have a root sign in the denominator. Can't have that. So we got to this point. I wanted to change this. What did it turn into? It turned into this. Okay, all these steps was to get this portion to look like this. This is called rationalizing your denominator. Okay, so if you need to go ahead and put it on pause, write all this down. I'm about to erase it, some of it. Okay. So what we have is plus 2 equals y. Remember, I just changed this into this. Okay, now 2, what is 2? 2 is 2 over 1. Okay, the number 2 is just 2 over 1. Right? 2 over 1. But let's kind of get this all underneath, all under one division sign throughout. So instead of 2 over 1, why don't we go ahead and write that as 4 over 2. So now I could add these together. What is that going to look like? It's going to look like cube root 4n, 4n, okay, plus 4 all over 2 equals y. Okay, now at this point we're done. So I'm going to go ahead and say that the inverse of f of n equals cube root 4n plus 4 over 2. And this is our answer. Okay, this is kind of a more advanced problem. I'm sure you guys can do this if you're following through. If you made it this far in your algebra, you understand your functions, you understand rationalizing your denominator, and you understand your rules for exponents, that you could do this. Okay, it's kind of lengthy, but I'm sure you guys can do it. You'll get a lot out of it. This is good for your mind. This is good exercise for your mind. Okay, another way to write this, if you say f, inverse f of n is 4 plus cube root 4n over 2. Okay, this is also allowed. What am I doing? I'm just taking this positive 4 and then just putting it out front. Okay, sometimes I like to draw the root signs like this with a little hook over the end. When it has this little hook, over the end, you know that it's not including whatever's past that. But just to be on the safe side, you could take this, move it out front, which is all I did. So there it is. Okay, step number 1, y equals 4 over negative x minus 2 plus 2. Step number 2, we're going to trade the x and the y. So then we have x equals 4 over negative y minus 2 plus 2. Okay, next step, we're going to get rid of this plus 2 by subtracting it from both sides. Remember, an equation is similar to a teeter-totter, that if I subtract 2 here, I need to subtract 2 here. So now I'm going to have x minus 2. I'm going to say that equals 4 divided by negative y minus 2. Okay, so now we're going to do a little algebra here, a little Vedic math type trick. So basically this x minus 2 is x minus 2 over 1. Okay, what I'm going to do is I'm going to swap places with these. This x minus 2 is going to go down here, and this negative y minus 2 is going to go up here. Just basically swapping these across. So I have negative y minus 2 over 1, or just negative y minus 2 equals 4 over x minus 2. Okay, next I want to add 2 to both sides. So we have negative y equals 4 over x minus 2 plus 2. Next step, I want to get rid of this negative sign to get y by itself. So I want to multiply both sides by a positive, or excuse me, multiply both sides by a negative 1. Right? Negative 1 times a negative will get rid of that negative sign. So basically what I'm doing is I'm multiplying all this times negative 1 and negative 1 times this side. So what that leaves me with is y equals, okay, that negative and this negative cancel out. And this negative 1 is going to be distributed in both of these terms here. So now I'm going to have negative 4 over x minus 2. Okay, that's this portion, negative 1 times the 4 over x minus 2. Now negative 1 times positive 2 is going to give me a negative 2. Okay, now what I want to do is I want to put this all underneath one rational expression. So to do that, I need to multiply this, call this negative 2 over 1 times x minus 2 over x minus 2. Okay, that gives us y equals negative 4 minus 2 times x minus 2 all over x minus 2. Okay, so we have y equals negative 4 minus 2 minus 2x plus 4 over x minus 2, or simply y equals negative 2x over x minus 2. Okay, at this point we're done. This is the inverse. So real quick, just to point out, this step here was to make it so that we can include this negative 2 underneath one rational function. There's another way to do it. Let me show you another way. Perhaps this is easier. This is actually the way I prefer to do it. The Vedic math. So what we had here is we had kind of this. Remember, we distributed this negative 1 in. So we got positive y minus 4 over x minus 2 minus 2. Okay, so basically to do the Vedic math version is instead of a 2, we're going to call this 2 over 1. Okay, I'm going to do our Vedic math vertically and crosswise fractions. Watch my video on Vedic math fractions. You could apply it to algebra. It makes it really easy. Basically what we're going to do is we're going to say negative 4 times 1 minus 2 times x minus 2. That's going to be your numerator. Negative 4 times 1 minus 2 times x minus 2. The denominator is just going to be multiplied straight across. So x minus 2 times 1. Okay, what we're left with, y equals negative 4 minus 2x plus 4 over x minus 2. Okay, distributing this negative 2 in gives us negative 2x plus 4. Here's negative 2x. Negative 2 times negative 2 gives us a positive 4. Okay, y equals negative 2x over x minus 2. Here's our answer. So we're going to say the inverse of f of x equals negative 2x over x minus 2. Okay, kind of a long process. I'm pretty sure you guys can do this. If you're good with your algebra, it may take a while. Just go through it again. Go through, if you need to pause it at a certain point, just press pause and look at it again. I'm hoping that I'm leading you guys on the right track and you're able to follow what I'm doing here. Okay, h of x equals cube root of x and minus 3. So first we're going to say y equals cube root of x minus 3. Next, we're going to swap y and x. So we're going to have x equals cube root of y minus 3. Okay, then I want to add 3 to both sides. So we have x plus 3 equals cube root of y. Okay, then simply cubing both sides. So now we have x plus 3 cubed equals y. And at that point, we're done. So we're going to say the inverse of h of x equals x plus 3 cubed. Okay, from this step to this step, what did we do? We simply cubed both sides. We did that to get rid of this cube root. Okay, so that's kind of the step that we did in between here and here. Okay, step number 1, we're going to say y equals 2x cubed plus 3. Step number 2, we're going to switch the variables x and y. So now we have x equals 2y cubed plus 3. Okay, we want to subtract 3 from both sides. Remember that an equation with an equal sign is kind of like a teeter-totter, right? Here's your equal sign. So we subtract 3 here. We need to subtract 3 here. This is the idea that I was telling you, transpose and apply, reverse engineering. Reverse engineering. That I subtract something here, I need to subtract it from this side. So we have x minus 3 equals 2y cubed. Next, we're going to divide by 2. Here, this y cubed is being multiplied by 2. So to get rid of it, we need to divide both sides by 2. So we're going to say x minus 3 divided by 2 equals y cubed. Last step, we're going to take the cube root of both sides to get rid of this exponent. This y is being raised to the third power. To get rid of that, we need to take the cube root. So we're going to say cube root x minus 3 over 2 equals y. And at this point, we're done. So we're going to say that the inverse of f of x equals cube root of x minus 3 over 2. That's it. There's your answer. Okay, I want to thank you guys for making it to the end of this video. Please press the like button and leave a comment. If you want to see more of these videos, subscribe for more videos. And just want to encourage you guys to work hard, write it down. You know, I know it can be tough if you're having trouble doing this, but just take it slow. Just press the pause button, reflect on what you're looking at, And I'm sure that you guys can do this. I'm absolutely positive that if I was able to if I was able to do my algebra growing up, you guys are fully capable of doing this. Just put your mind to it and stay positive.